Okay, so part two of the within participants, within subjects, sorry, mixed ANOVA, get there eventually. We've done a mixed ANOVA, and we found that there was, just to recap, there was a significant, no significant main effect of either occupation, which was psychology or engineering, or shape, rectangle versus oval, and there were no significant, but there was a significant interaction, as we saw on these graphs here. Psychologists seem to be better at rectangles than engineers were, or if you want to put it a different way, psychology was better at rectangles than they were at ovals, and engineers were better at ovals than engineers, which gives us a crossover interaction. When we did the simple main effects, we did it within participants ANOVA and found there was no significant effect of shape, so it wasn't the case that overall, ignoring occupation, that shapes were better than, rectangles were better than ovals, or ovals were better than shapes. When we looked at the between subjects t-tests, and what we did here was to see, well, okay, if we look at this top one here, it says group statistics, we can see that if we compare psychologists versus engineering students on rectangles, there's a small difference in the means here. And we look at psychology, so that in the sense that psychologists are slightly better, we kind of knew that from the graph. And we look at ovals, then psychology students are slightly worse than engineers. We knew that from the graph, 7.7 versus 7.2. But neither of these t-tests is significant. Okay, so there we go. Equal variance is not assumed. We're okay to do to assume that because Levine's test is non-significant in both cases, and we find that the t value is non-significant here, 0.38 versus 0.268. So neither of the. So basically, what we found here is no significant main effect of profession, no significant main effect of shape, a significant interaction. But when we examine that interaction, we find that none of the pairwise comparisons is significant, which is odd. But let's have a look at this graph again, because this graph seems to suggest that there's a substantial difference between psychologists, for example, in their abilities to identify rectangles at the top and their ability to identify ovals at the bottom. But that's because the graph is rather misleading. If you look at the y-axis, y's up, remember, then it starts at 7.2 and ends at 7.9. Let's fiddle with that. So if you double click on the axis there, we can get this up. If we double click here, then we can get this up, and then if we go to scale, we can actually set this axis, we can force it to start at 0, which is where the score starts. The minimum number of shapes you can identify is 0, so that's where we should have 0 in there. So we click apply, and then close, and then let's close this down. This is what the graph actually looks like when you look at 0. So you can see what looked like a very impressive interaction is actually tiny. The differences between psychologists and engineers on shape is only a very small amount, and this is reflected in the means. If you go and look at the means, this is what the means are telling us too. It's 7.6 versus 7.2 or something. The same here. So this is why we're getting an overall significant interaction between the two variables, but actually none of the pairwise comparisons is significant. So you'd have to write that up by saying overall there was no significant main effects of psychology, occupation and shape, but there was a significant interaction, suggesting that possibly psychologists are better at rectangles than engineers, and vice versa. But when we examined the pairwise comparisons, none of these were significant, so it's difficult to make any kind of claim of who is better. And this may be partly due to the fact, if we go back to the data sheet here, go back to the correct data sheet, it'd be even better. We've only actually got 24 participants, so maybe the power of this study isn't very high. Okay, that concludes this particular screencast. Thank you.